All right. Then good evening or good morning or good afternoon, depending on where you are. Welcome to our today's webinar. My name is Thomas van Beera. I'm the Vice President of Business at Apex.AI, and it's a pleasure to have you here. I appreciate you taking the time to join us. Together with me is Alexander Wisniewski from our long-term partner driveblocks. Great to have you for first. Alexander is Managing Director at driveblocks. He drives the product strategy and the architecture for scalable autonomy, especially in agriculture and construction machinery off-highway segment. And today he will be discussing options how you can accelerate your software development, especially in these domains. So in this webinar, we are targeting high-performance computing systems with a high sensor data throughput, and especially for reliable perception systems such as driveblocks AI. The goal is to provide you with valuable insights that you can also apply to your own projects. So more than happy that Alexander is able to share his experience here. It might be beneficial for you, especially when you are considering to bring your prototypes, your research work into real-world industrial applications. I'm not alone here in the office in Stuttgart in Germany. I'm joined today by my colleague, Lore Beck, from our business team here in Europe. And she will manage the Q&A session at the end. So if you have any question already during the presentation, please feel free to submit it. Already during the session, you find a Q&A button at the bottom of the Zoom screen. So please use the Q&A button at the bottom of the Zoom screen to provide your questions already during the presentation. At the end of the session, we will go through as many of your questions as possible, and we will provide detailed answers. With that said, let's get started. Alexander, perception systems, agriculture, construction, rough industries, high variances. Really curious to learn how your perception stacks evolves from lab to field. So what are the challenges you have to cope with?
All right. Yeah. First, thanks a lot for the invitation, Thomas. I'm happy to be here and speak about what we have been doing together over the past years actually already. So diving a little bit deeper into what Thomas has already shared is that we have looked in the past years very deeply into all types of different off-highway applications. And off-highway applications can actually be very, very diverse, right? So it can be in agriculture, things like mowing, tillage, soil cultivation, in construction and mining, paved area logistics, defense and off-road logistics. So there's a wide variety of different applications. But what we have seen is that pretty much all of them face similar challenges when moving from automation, so GNSS-based functionalities, to full autonomy, meaning it's sensor-based, actually really independent machines being able to make independent decisions. So these challenges are heavily related to the task of perception and environmental understanding. For one of them is actually operation unstructured environment. You don't have lane markings, you don't have kind of like a reliable structure where you can work through, similar as in the on-road scenarios. There you need to be able to detect persons, obstacles, and vehicles in very weird and obstructed scenarios. So pretty much everything can happen there. There's a huge diversity. And finally, you need to be able to have reliable perception and sensor fusion across all types of conditions, because these machines need to work 24/7. This is not a driver assistance system, which can work when it's nice and sunny, and it can't work when it's getting rainy, when it's getting dusty. The actually end users are going to expect these machines to work reliably over all types of conditions to provide real business value. So we have set out to solve these challenges by combining highly efficient embedded AI, sensor fusion, and a solid approach to certification. Because this is a timely and cost heavy endeavor, we believe it makes sense to offer this to other people to build on top of this. So what is a typical sensor set for agricultural autonomy applications? From a system point of view, you need to kind of like be able to drive up to 20, 25 kph. You need to manage harsh conditions like vibrations, oscillations, dust, muddy conditions. You need to detect other vehicles also with speeds to up to 25 kph. And you need to have a safety zone or a hazard zone directly around the machine for an area of around 10 meters, which is fully safety relevant and is going to trigger kind of like an emergency braking or evasion maneuver. From this, there are coming a few perception requirements for this environmental understanding. And these are, first of all, and that's actually a very important thing, is that it needs to work up with different speeds of up to 50 kilometers per hour. And this is already quite a bit if you consider that many sensors which are ready and available today only have update rates of 100 milliseconds. So kind of like if you do the math there, this means that you get around 1.4, 1.5 meters of motion between two consecutive frames, which makes it hard to do data association. In terms of perception range, you need to achieve 20, 25 meters, sometimes 30 meters, depending on the speed. And kind of like adding all of that up, this means that you kind of like end up at around 500 milliseconds of total delay between seeing an object for the first time and actually initiating an emergency brake. In terms of sensor setup, we see that the most applications are kind of like targeting a full 360-degree setup with two sensor modalities, meaning there's usually around 5 to 6 cameras, 2 megapixels is the standard choice, and LIDARs, where the trend is going more and more towards directional LIDARs. So 120-degree opening angle, more mid-range oriented things, and there are actually quite some attractive cost-effective options available. Going next. Yeah, so if you do kind of like the analysis then, and I think that's kind of like now coming towards the topic of this webinar, is what we have found is that kind of like it's very easy to underestimate what needs to go on under the hood to make such a perception system work reliably. And if you do the math, you kind of like come up with that in terms of the data throughput, you roughly get with the 6 cameras and 3 LiDAR scanners, you roughly get 42 megabytes of data per sensor cycle. In total, this means with a 10 hertz update rate, and this is still, let's say, on the slow side, this already gives you a data throughput of more than 400 megabytes per second, which is very, very substantial compared to the data throughputs which we have in today's electrical architectures in agriculture autonomy. On the compute side, kind of like the standard is that we are seeing variations of ARM-based platforms ranging from 4 cores with moderate cycle rates up to 12 cores with very high frequencies. So there's a broad variety. On the AI accelerator side, it's actually kind of like we see 2 kind of like platforms being very prominent. There's obviously others, but these 2 are kind of like the 2 major ones which we are seeing when working with customers and partners. It's the NVIDIA ecosystem and also the Halo 8 ecosystem. And kind of like I think the point we want to make here is while these compute platforms sound pretty powerful, the sheer amount of data and processing to give a 2 modality 360-degree perception with the requirements which we have laid out earlier is actually a pretty huge challenge. And yeah, so what happens if you kind of like as we did like 3 years ago, took our work from research, from kind of like a lab environment into more like moving more and more towards production deployments. So kind of like initially, we have started out to working with ROS2. It's a great and proven robotics software framework. There's a great ecosystem of tutorials. Developers, the team knew it from university, from courses, from open source projects, and it's really easy to use. So kind of like it was a pretty much a no-brainer. A lot of our customers and partners are also still using it. But kind of like as soon as you start using this for kind of like really like long time, you have kind of like demonstrators out there running, kind of like sometimes strange things start to happen. And yeah, I want to share a few findings which we had over the years. So one of them is that we found that messages are, let's say, or message transport reliability is quite depending on the load of the system. So if the system really has a ton of resources, message transport is very reliable in ROS2. But as soon as you reach like 50, 60% of the like CPU load, messages start to drop randomly, and kind of like the same happens for high network load. And that's something you don't want to have in a production grade system. Strange things start to happen also every now and then, and you want to be able to reproduce these situations with the team afterwards based on your logs. But because the open source ROS2 framework doesn't give you a clearly and reproducible like execution and deterministic replay, your team will very often not be able to reproduce these findings. One other, let's say, pretty interesting finding is, which you get over time, and I think a lot of people who are working long time with ROS2 can relate to this, is like from time to time it happens that like some open source package gets updated and suddenly your software doesn't build anymore because something is not available anymore, some kind of like authentication procedures are not working anymore, some APIs have been breaking and so on. So kind of like yeah, this is creating some kind of risk, especially to some operational things. If you have machines out there kind of like testing a lot, which are not supervised by engineers all the time. And finally, we are seeing that kind of like because of the very high data throughput, there's also some challenges in the data recording procedure where sometimes it just doesn't work reliably because kind of like the system is not like inherently designed to be 100% reliable. All right. Moving next, so kind of like with all these findings, we step by step, yeah, kind of like thought about how we gonna approach this, and that was when we were starting to work closer and closer with the Apex team, and yeah, we wanted to improve upon to be a little bit more specific on the challenges we have mentioned earlier. We really wanted to improve on things like scheduling conflicts from the different workloads across on this multi-core system. We wanted to achieve full reproducible and control about how our executables and our workloads are processed on the ECU. And we wanted to kind of like not spend additional resources on data transport because our algorithms are already pretty heavy. So what we did is basically we took a lot of our workloads from ROS2 Galactic to the Apex framework. That porting is something we found was pretty straightforward because it's actually the kind of like it's a very similar style of working with the Apex.OS. When you come from ROS2 Galactic, so usually it takes you only a day or very few days to port already complex workloads from ROS2 Galactic to Apex.OS if you have some practice. And then we started diving deep into this using tracing tools like LTTNG, analysis with Trace Compass to understand really whether we're getting the advantages which we want to have from the Apex framework. And we have some of these results here, kind of like what we see, and I think this is reflecting these qualitative insights I've shared earlier, is that with ROS2 Galactic in our perception system, we kind of like have a very high variance in our like total end-to-end latency. And this end-to-end latency covers everything from data input up to output of the perception system. You see that there's a variance between like 35 milliseconds up to 90 milliseconds here. And this basically means that you have to, like in the worst case, a 3 times higher execution time. And this is coming from all types of effects which are playing together, and you have to tackle all of these things. And kind of like when we were moving our workloads to the Apex.OS, we found that we could reduce average execution time from around 65 to 40 milliseconds, and worst case execution time we could basically reduce by up to 50%. And the remaining variance is something when we were diving deeper into this, which was basically algorithmic variance. So kind of like we could really achieve what we wanted is basically that we do not have to kind of like figure out how ROS2 is doing things under the hood, and that we had full control over these data transport and execution workloads. Going next. So why does all of that matter? Like something which we see especially in sensor fusion systems, so systems where you have multiple sensors of one modality and probably also multiple modalities. In this case, there was kind of like a multi-sensor setup. You need to do data association, right? You need to have timestamps on every data frame, and you also need to make sure that this sensor data is at the same time in every part of your processing toolchain. So something we found early on is like with open source ROS2, we had challenges, especially with small object data association, because we couldn't reproduce the timing. So that was something we could substantially improve when we were working or when we were moving the workloads from ROS2 to Apex.OS and achieve much higher perception, precision, and reliability by doing so. The second thing we want to mention here is that kind of like the impact of this total end-to-end timing. And I think that's something which is heavily underestimated because what we see is like, no, I think we're good with moving to the next slide. So what we see here, and this is just like one of the examples we had in our recordings, is Like, for example, this tractor is only 20 meters away, and you need to have really good understanding of what it's going to do. Is it driving like in parallel to the ego vehicle, or is it driving maybe towards you, and you need to initiate an emergency maneuver or kind of like evasion maneuver? And for this, it's really reliable to have fast and quick execution and kind of like reaction times. And when we did the analysis on the overall system, we found that basically just from the switch of the underlying middleware, we could reduce our end-to-end latency and our end-to-end reaction time, and therefore also the reaction way, between 1 and 4 meters, depending on the situation. And this is really a lot if you consider that the total perception range of these systems is targeted to be around 30 meters. This is already kind of like 15 to 20%. And that's a very substantial improvement, which gives us some headroom to also kind of like spend more compute and spend more resources on the actual algorithms and not on the underlying functionality. Going next, so I think to summarize that up a little bit, like what we have found over the years when working in the industrial autonomy space and kind of like the agriculture space is one of the most prominent in there, is that kind of like most projects go like this, that you like initially think autonomy is all about things like fleet management, work process automation, motion planning, perception, and safeguarding. And at some point, kind of like the team gets kind of like, really busy with all the things which are actually, let's say, below the water level of an iceberg. So that means things like AI deployments on some embedded hardware, data management with like tons of terabytes of data. You need to kind of like allocate all of this, kind of like figure out how to manage your huge data pool. You need to dive really deep into all of these like low-level things like data transport, execution, configuration management, diagnosis, and so on. So kind of like there's a ton of things which you have to consider, and kind of like I think all of these are kind of like heavily underestimated. And something which we have learned, or what we're seeing, is that all of these things become gradually more important when you move from prototyping towards production. Right. So
it's on me. Moving from prototype to production. So therefore you need a software foundation that enables complex safety critical applications without even requiring a specific operating system. So and this is where Apex.OS comes into play. So our architecture is supporting different real-time operating systems, different system on chip platforms, and therefore it brings the flexibility and also the adaptability even to develop hardware agnostics, hardware agnostic. And this allows you to work on a seamless integratable functions and algorithms optimized for real-time performance, independent from the underlying hardware. So we support various POSIX-based real-time operating systems and a wide range of different system-on-chip environments from different vendors. So, and this is also kind of domain freedom. So really from tractors to medical equipment, everything is possible. So what is the product or what are the products and offerings Apex AI has? So in the end, we are based on ROS2, and therefore we made open source software to source available software you can purchase under license. So you get a fully fledged developer efficient software framework, which is called Apex Grace. Underneath, there is the data transport layer. It's called Apex LIDAR. So it's a high performant data transport across processes, ECUs, and domains. I will detail a bit more later on. Aside that, we are also offering services and a variety of tools. Worth to be mentioned is for sure Apex Allen, which is an automated continuous integration, continuous deployment environment, and also profound test infrastructure. We offer as an IP service, IP transfer service. So we really build up a good state-of-the-art solid CI/CD for our customers, which is production ready. And when it comes to type approvals, certifications, homologation, the Apex.OS for verification and validation comes into play. And here also Alex mentioned it, determinism, record, replay, reproducibility is important. And this is exactly the handy tools you need for reproducible validation and safety cases. What is contained, starting with Apex.OS, the SDK. So we are providing essential tools for the developers. So Apex.OS equips the teams with the resources they need to accelerate their development process. So different libraries, different tools, and also safety certification options, everything combined in one SDK. And so that you really can focus on your functionality, on the creation of your algorithms, on the creation of your artificial intelligence, and your end products, but you don't have to deal with everything underneath. So as mentioned, source available software under commercial license, it's also appealing to the developers out of the huge ROS2 community. So Apex AI is for a long time tied to ROS and also one of the main contributors till today to the open source initiative. But with this source available software here, all the C++ 1721 developers are really happy also to work on production systems and not only in research. And it is really ready to scale. So we have big customers and also orchestrating a lot of suppliers for the integration. Good part is Apex.OS is safety element out of context, certified according to ISO 26262. You will say, "Oh, how is this related to the agricultural industry?" For sure, it's tied to the overarching norm, like the IEC 61508 and the agricultural safety standard. So ISO 25119, the AGPL, is an adjacent norm. So you will get all the handy tools to make your in-context certification and the safety manuals from us. Apex IDA underneath as a data transport layer. It's a real benchmark in the industry, and we also invite you to benchmark. So it is able to move large amounts of data between multiple systems or applications really efficiently and securely. No risk of loss or corruption. Yeah. It really handles also the translation of different communication protocols and buses. So really ensuring seamless data exchange across different systems, but also following different patterns and mechanisms. It is already out of the box, ready to be used also with specific description languages you might already have from legacy systems. And it's very compatible on the wire also to legacy systems like AUTOSAR, for example. Combined with really efficient zero copy mechanisms, various interfaces, it's easy to config also for the developers, so that as a developer, you don't have to deal with all the protocol stuff. You only need to know what kind of data you need. Yeah? And we are driving systems up to 100 gigabit per second, and we are a kind of benchmark according to our customers. And also the figures and data Alexander showed earlier, you can find also online in our white paper library on our website. So Apex IDA combines high throughput. We are supporting various real-time operating systems. We are able to bridge different hypervisors with high throughput capabilities. And this is really ready if you need high performance communication across processes, across ECUs, across hypervisors, across domains, into infrastructure for systems and systems of systems communication. And with that, we come back to the big systems, Alexander.
All right. So kind of like as a summary, or kind of like building up on what Thomas has just shared, like we believe that it makes a lot of sense to build up on pre-integrated technology, because what we are seeing is that especially in the off-road domain, one of the key roadblocks in getting autonomy out there and to provide real customer values are the investments and the time required between kind of like, going from a prototype up to actually generating meaningful revenue for the OEMs. And working with the pre-integrated tech stack is actually a strategy to help and mitigate these challenges, because it actually allows you to focus on the differentiating factors such as automation of the work process and the vehicle operator experience. So the user interface, the way the machine should actually perform its work process. That's where most of the companies have very strong heritage already and a very strong experience in, and kind of like a pre-integrated solution of the driveblocks perception and sensor fusion stack with Apex.OS allows you to do that seamlessly. It kind of like allows you to save integration costs through working with pre-integrated suppliers. So instead of kind of like figuring out who could be potential suppliers and doing all the like glue coding and plumbing, putting everything together, pretty much everything just works out of the box. And I think, the two actually most important points, and these are actually, I think, the key points we want to make here is working with a pre-integrated solution allows you to reduce integration risks and unknown surprises. And these unknown surprises are, I think, pretty much the reflection of this iceberg, which we were showing earlier. All of these surprises you find when going from prototyping towards more production grade deployments, towards more production grade ECUs, kind of like building with the tech stack, which has already been going through this hardening as much as possible, is something which really ensures that everybody can meet its timeline and reduce the risks which are associated to these innovative technologies. Last but not least, we want to invite you to experience this. So we have a demo vehicle available. It's actually located in Munich. We're more than happy to visit you in most areas of the where it's possible. It's probably not possible to take the vehicle to the US, but we're definitely more than happy to go around Europe and do live demos and demonstrate how the perception system and a build on top of Apex.OS is working. And it's an off-road vehicle, so we are pretty good to go wherever you think is most appropriate for testing agricultural autonomy systems. All right, thank you very much, and we're happy to hear your questions and happy to discuss.
Thank you, Alexander. So this brings us towards the end of today's session. But now we are open for your questions. So please use the Q&A button at the bottom of the Zoom window. And my colleague Laura, she will sort out also your questions. We will moderate the session now. Aside that, for sure, we also value your feedback very highly. So please let us know what we can improve also. But with that said, keen to learn what questions might have come up. And not to forget, thank you, Alexander, for supporting this.
Thank you, Thomas. So also Lyle joined us from Apex AI for the Q&A session. So we have only one question up to now. So if you have still something in mind, please feel free to post it using the Q&A button below. So the question was up to now is how experienced was the team using it? Alex.
Yeah, so I assume, and I think this question came up when I was speaking about the porting from ROS 2 to Apex.OS. So the team, let's say the people doing it had quite some experience in developing applications in ROS 2, so several years of C++ experience and also the development with ROS 2. And I think kind of like what was important to us that we could see that we could transfer this kind of like experience to kind of like the software framework, and we didn't have to build up the experience again for a totally different way of working. But in general, kind of like think of like a 2 to 3 year experience with ROS 2, and that's kind of like made the transition, I think, super easy.
I would agree that that is ideal. We have had folks who are just solid C++ programmers or a team of solid C++ programmers, and they have a slightly larger learning curve because there are some concepts introduced in ROS that, you know, just take a little bit of familiarization, like their parameter server, for example. But once these core concepts are understood, then, you know, you're well on your way and just, you know, using the APIs as they are and saving yourself a lot of time.
So is there another question coming up? Not so. I will give over to Thomas again. Thanks.
Thank you, Lore. Yeah, with that brings us also already to the end, yeah, of today's session. So thank you all for your time and your engagement, especially Alexander from driveblocks AI. Really great to have you here. Please note that this webinar is part of a series where with partners, with customers, we are hosting different industry-specific sessions. So with these guest speakers from the industry, you will get some deeper knowledge around applying state-of-the-art technologies to develop autonomous systems. And as mentioned, we also highly value your feedback. So please let us know how we can improve future sessions. Also, if you have ideas for applications, let us know. And additionally, if you are interested in exploring this further, I encourage you to check out our white papers and blog posts for more insights, and also the driveblocks AI website. And of course, if you'd like to evaluate our solutions, please feel free to reach out. We'd be happy to discuss your specific use cases. And finally, big thanks to my colleagues, Lore, Lyle, and for sure, Alexander, for supporting today. And with that, I look forward to continuing the conversation. Thank you and have a great day.